Hello, welcome to the second deep dive into Springer-Verlags' new ebook from the Human-Computer Interaction series, Human-Centered AI. This is a 695-page ebook containing articles by scientists from various countries. I would like to introduce you to a few of them. In the previous video, our first look at the book, we explored an article by a scientist from Portugal and learned that AI has now evolved to the point where there are different types of AI and different classifications. Furthermore, the book is about human-centered AI, the approach to developing AI systems that focuses on the benefit of humans. This means that AI had to be efficient, technologically advanced, and also ethical, safe, transparent, and designed to complement human capabilities and promote human well-being. This type of AI is particularly useful in healthcare, education, the workplace, and public administration. Other types of AI can be defined according to different criteria. For example, by capabilities and application area, by technological foundation, and so on. Today I would like to introduce you to another article from the book which deals with the new third type of user interfaces, conversational user interfaces, and such agents. This article is called Conversational User Interfaces and Agents. It was written by scientists from Italy. And before I introduced you to this article, I made also a video about conversational user interfaces from another sources, not from the book, but from another sources. This video you can find in the playlist to this ebook. The article Conversational User Interfaces and Agents can be found in the book from the page 399 to the page 438. And now I give a word to Notebook LM audio summary to this article and show you the schemas from this article. There are only 4 of them.
Welcome to the Deep Dive, your shortcut to understanding complex worlds. Today we are really getting into it. Conversational agents, CAs, and the thing we probably all call chatbots now.
Right. Yeah. These are basically the AI systems that, simulate talking to a human. They use natural language, could be spoken, could be written text.
And our mission today really is to give you a clear map of this whole tech landscape. We want to distinguish between, say, the simpler systems maybe built on rules and the really complex ones using massive neural networks.
Exactly. And it's funny, CAs feel so cutting edge, right? Very AI now. But our sources show the basic ideas. They're actually decades old.
Oh, yeah. How far back are we talking?
We're talking 1960s. The classic example is ELIZA.
Eliza from MIT, right, back in 66.
That's the one developed by Joseph Weizenbaum. And what's really wild about ELIZA is how well it faked being a therapist. It could genuinely trick people.
But it wasn't actually understanding anything, was it?
Not really, no. It was mostly just clever keyword matching. It would spot a word like mother and spit back a pre-written rule like, tell me more about your family. Minimal context.
Wow. So simple, but effective. It kind of shows how much we project meaning onto conversations.
It really does. So fast forward to today. The AI underneath has totally transformed. We've gone from those basic templates to, incredibly complex, deep neural networks. But the terms chatbots and CAs, they're kind of used interchangeably now.
Right.
So yeah, our job is to unpack that dual nature, look at the sort of reliable, old school, modular way versus these newer, maybe more powerful end-to-end systems.
Okay, let's unpack this. Maybe let's start with where you, the listener, are most likely running into these systems day to day.
Sounds good. We can basically break down where they're used into 4 main areas, 4 domains. Each one kind of optimizes for something different. First, and probably the most common, is general purpose. This is your everyday stuff, like asking a smart speaker a question, getting help on an e-commerce site, controlling your smart home, basic question answering, that sort of thing.
Right, the utility stuff. So what makes the next domain, the technical one, different? Is it just harder problems?
Yeah, essentially. The technical domain involves, well, higher complexity, higher stakes, often. Think about managing complex IT systems or really deep technical support for end users. And the big one, autonomous call centers. Handling thousands of calls an hour. Accuracy there is absolutely critical.
Okay, that makes sense. Now, shifting gears quite a bit,
Yeah.
what about areas where it's less about pure function and more about, I don't know, connection, like healthcare?
Exactly. In healthcare, CAs are doing some really interesting, sensitive work. Often non-critical tasks, mind you, but still vital. Things like helping patients stick to their medication schedules, super important, or patient engagement, maybe helping someone track side effects during cancer treatment, offering support.
Hmm.
And even initial support for mental health concerns. It's a growing area.
So for that, the design has to be totally different, right? It needs rapport, maybe even empathy, not just speed.
Precisely. It has to align with the user's emotional state, not just their need for information, which leads perfectly into the last big domain, education. Here, CAs offer, well, scalability for knowledge sharing, but also really crucial specialized support. Things like personalized learning, help for visually impaired adults, or specific language practice tools for deaf children. Really valuable applications.
So with all these different uses, it sounds like there are two basic design philosophies clashing or maybe complementing each other. The fast get-it-done transaction versus the more personalized chat.
That's a great way to put it. It's the core design tension. You have task-centric systems. Their goal is efficiency, speed, accuracy. Think booking a flight. You want clear, concise, direct communication. Get the task done fast.
Right. I don't need small talk when I'm just trying to confirm my seat number.
Exactly. But then if you're discussing, say, a health issue or trying to learn something new, speed isn't the main thing. Feeling understood is.
Okay, so that's the other side.
That's the user-centric agent. It's all about personalizing the experience, building that rapport, adapting its behavior. This is where, a bit of small talk, remembering past interactions, showing empathy, that actually makes the system more effective for its purpose.
Interesting. So it's not just fluff.
Not at all. And often the sweet spot, as the research suggests, is probably some kind of hybrid. Efficient enough for the task, but personalized enough to keep you engaged. Okay, so now, how do these things actually work under the hood? If we think about a modern CA, especially one that handles voice, there's a standard kind of pipeline it follows. Starts with ASR, automatic speech recognition.
Takes your voice, turns it into text.
Yep. Then NLU, natural language understanding.
Figures out what the text means.
Then DM, dialogue management.
Decides what to do or say next. The brain, kinda?
Pretty much. Then NLG, natural language generation.
Crafts the reply in text.
And finally, TTS, text-to-speech synthesis.
Turns the text reply back into voice. Okay, ASR, NLU, DM, NLG, TTS.
But whether you're typing or talking, the real sort of cognitive work, the core intelligence, happens in those middle three. NLU, DM, and NLG.
Understanding, managing, generating.
Right. And how those three pieces are built, that defines the whole architecture.
Okay, here's where it gets really interesting. Let's break down the two main ways people build these CAs, starting with the one that, maybe still runs a lot of the reliable services we use, the modular architecture.
Exactly. You can think of it like an assembly line. Modular CAs are often preferred for reliability in specific tasks, precisely because they break the problem down into these separate, manageable steps. It's very structured.
So distinct modules doing specific jobs was the first module in that line.
That would be the natural language understanding module, the NLU. Its job is to make sense of what the user just said or typed.
Okay, and you mentioned NLU has two key tasks for the next stage, the dialogue manager.
That's right. Job one is intent recognition. Basically, figuring out the user's goal. Are they trying to book something, cancel something, ask for information?
Makes sense.
Yeah.
And the second job?
Entity recognition. This is about pulling out the crucial details from the user's input, the specifics, like names, dates, locations, product codes, or whatever is relevant to the intent.
So if I say, book a flight to London for next Tuesday, NLU flags the intent as book flight and tags London as the destination and next Tuesday as the date.
Perfectly put. Once NLU has done that, it passes that structured information, the intent, and the entities over to the central component, the dialogue manager, or DM.
The brain, as we called it. This manages the actual flow of the conversation.
Exactly. And the DM itself has two really important subparts that are key to making the conversation feel coherent, not just random.
Okay, let's zoom in on those. What are they?
First, there's the dialogue state tracker, the DST. Think of this like the chatbot's working memory. It's short-term memory. It keeps track of the conversation history, the context, what's been said and decided so far.
So going back to my flight example, if I say I want a flight to London, the DST notes London as the destination.
Right. And then if your next turn is make it for next Tuesday, the DST just updates the state with the date information. It doesn't forget you already said London. It maintains that context across turns.
Crucial for a real conversation.
Right.
Okay, what's the second part of the DM?
That's the dialogue policy, or DP. This is the decision-making logic. It looks at the current state, what the DST knows, and decides what the system should do next. Should it ask for more information, like which airline? Or should it maybe query a database? Or confirm the booking? Or even apologize if it can't fulfill the request. The DP chooses the next system action.
Okay, so NLU understands, DST remembers, DP decides. That sounds very logical, very structured. Makes the system probably easier to debug and reliable for specific flows.
It absolutely does. Highly auditable.
But if this assembly line works so well for certain things, why the big push towards this other approach? The end-to-end architecture. What's the downside of being so modular?
Yeah, that's the core tension. Modularity gives you reliability within a defined scope, but it can be brittle. Flexibility is the trade-off. If a user asks something just slightly off script or uses phrasing the NLU wasn't explicitly trained on, the whole thing can just break. The NLU fails to map the input to a known intent or extract the right entities, and the conversation grinds to a halt.
Ah, the classic, sorry, didn't understand that loop.
Exactly. End-to-end CAs aim to overcome that rigidity.
So, end-to-end. These systems learn how to converse directly from vast amounts of data, right? Often using just one big comprehensive neural network instead of separate hand-tuned modules.
That's the idea. It was a shift driven entirely by breakthroughs in deep learning. Early attempts used things like recurrent neural networks, RNNs. They helped process sequences like text.
But they had problems, didn't they? Like forgetting things from earlier in a long sentence.
Big time. The infamous vanishing gradient problem, among others. They struggled with long-range dependencies. Solutions like LSTM, long short-term memory, and GRUs were developed to help mitigate that, to give the network better memory.
But the real revolution came later.
Yes. The absolute game changer was the transformer model.
From that huge paper, Attention is all you need. Everyone talks about transformers. What was the key innovation there? Why was it such a leap?
The core mechanism is self-attention. Instead of processing a sentence word by word sequentially, like RNNs did, transformers can look at all the words in the input at the same time and figure out how relevant each word is to every other word.
Okay, so it gets the context of the whole sentence instantly.
In a sense, yes. It weighs the importance of different words relative to each other. This departure from strict sequential processing was massive. It allows for parallel processing, making training much faster on modern hardware. And crucially, it handles long-range contextual information much, much better than RNNs ever could. That's essential for fluid, complex dialogue.
Right. And that architectural shift, the transformer, it also changed how we even represent words for the AI, didn't it? Moving beyond static meanings.
Absolutely. We shifted from older methods like word2vec, where a word like bank always had the same fixed numerical representation.
Regardless of whether you meant a river bank or a financial bank.
Exactly. The transformer enabled deep contextual models. Think Elmo, and then the really big ones like BERT and the GPT series. These models generate word embeddings, word meanings that change based on the surrounding words in that specific sentence. The meaning of bank adapts to the context.
Which gives the AI a much richer, more nuanced understanding of language. Unparalleled semantic understanding, really.
Precisely.
Okay, so now we have these powerful end-to-end systems fueled by transformers and contextual understanding, giving them amazing memory and context awareness. Let's look at some of the really complex multi-turn problems that this kind of architecture allows CAs to finally tackle effectively.
Right. Let's circle back to question answering systems, or QA. Historically, you had classic QA. These were mostly isolated interactions. You ask a question, you get an answer. Ask another question, get another answer. Each one separate.
Which meant you, the user, had to formulate each question perfectly, making sure it contained all the necessary context, right? A bit unnatural.
Very unnatural. It put a high cognitive load on the user. You couldn't rely on conversational flow.
Like if I ask, who directed The Godfather, and get the answer, I couldn't just follow up with what else did he direct. The classic system wouldn't know who he referred to.
Exactly. That requires memory. That's where conversational QA or co-QA comes in,
Yeah.
powered by these newer architectures. Co-QA systems are specifically designed to address that memory limitation. They retain information from previous turns in the dialogue.
So they know who he is.
Yes, they leverage the dialogue history, allowing for follow-up questions, clarifications, using pronouns. It makes the whole information-seeking process feel much more natural, much more like a real conversation across multiple turns.
That makes a huge difference. Okay, what's another area where this memory and context is critical?
Another really interesting application is conversational recommender systems, or CRSs.
Okay, so these aren't just static recommendation engines like on Amazon. They actually talk to you.
Right. They're designed to help you achieve a recommendation goal, finding a movie, planning a trip, picking a product through a multi-turn dialogue.
Instead of just clicking filters and checkboxes.
Exactly. But the big challenge for CRSs is efficiency. How do you figure out what the user wants without an endless back and forth?
Yeah, nobody wants a 20-question interview just to find a restaurant.
Right. So a key performance metric is often the number of interaction turns it takes before the user accepts a recommendation. Fewer turns is better.
So how do they manage that? How do they gather your preferences quickly?
Well, one sophisticated technique many CRSs use is called the critiquing approach.
Critiquing, how does that work?
Instead of asking you up front, what's your budget? What features do you want? The system might offer an initial suggestion, maybe a specific camera model.
Okay.
Then you provide a critique based on that suggestion. You might say, that's a bit too expensive, or I need something with better zoom, or is there a lighter option?
So you react to a concrete example rather than trying to define your needs in the abstract.
Precisely. And the system uses your critique, cheaper, better zoom, lighter, to instantly refine its understanding of your preferences and narrow down the options for the next suggestion.
Like a rapid filtering process guided by your reactions.
Exactly. And some systems get even smarter. They use things like compound critiquing. The system might proactively suggest a critique that combines attributes, like asking, would you prefer something less expensive and lighter?
Because that combined critique might eliminate a whole bunch of options at once.
You got it. It helps the system converge on a good recommendation much faster, reducing those interaction cycles. It's quite clever. So if we sort of zoom out now and connect this to the bigger picture, we have these incredibly powerful large language models, LLMs, like the ones behind ChatGPT, Bard, and so on. They're amazing, but what's next? What are the big hurdles and future leaps?
Well, one obvious challenge is just their sheer scale, right? These models are enormous. Training them takes immense resources. Running them is expensive. They're not practical for every single application.
That's a huge factor, and it leads directly into one major future direction. Task-specific LLMs. Instead of one giant model trying to do everything, the idea is to train smaller, more efficient LLMs, each specialized for a particular task. Maybe one for booking travel, one for technical support, one for healthcare advice.
Okay, smaller, focused models. But how do they work together?
That's the key. They would likely be coordinated by another AI, maybe a larger, more general LLM planner. This planner understands the user's overall goal and routes parts of the conversation to the appropriate specialist LLM.
Interesting. So you get efficiency and customization
Great.
from the small models, but the complexity shifts a bit to coordinating them all.
Exactly. Orchestration becomes the new challenge. Another big wave, which we're already seeing, is multimodality.
Meaning more than just text.
Way more than just text. Integrating other types of data images, audio, maybe even video directly into the conversation. Imagine, showing your CA a picture of a weird plant in your garden and asking, what is this and is it poisonous? Or holding up a broken appliance part.
Instead of trying to describe it in words, that would be incredibly useful. Much richer context.
Totally. It brings the AI closer to understanding the world the way we do, through multiple senses.
Okay, specialized models, multimodality. But what about the ultimate goal, the sort of holy grail of conversational AI?
That would have to be the truly unified dialogue system. Meaning the seamless blending of task-oriented dialogue, like actually doing something complex, booking that multi-city trip with non-task-oriented interaction, like casual chit-chat, relationship building, empathy.
So the system can help me plan my vacation logistics and ask me how my day was and switch between those modes fluidly.
That's the dream. Systems like UNIDS are already exploring this, using these powerful end-to-end LLM architectures. The goal is to bypass the need for those huge, manually labeled datasets that older modular systems relied on for every specific task and for chit-chat separately. The LLM learns to handle both, potentially, from its vast training data.
That feels like the path towards truly human-like conversational ability.
It really does. That kind of fluidity is key.
Wow. Okay, so we've covered a ton of ground today. We went all the way back to Eliza in the 60s doing its clever keyword tricks, through the reliable structured modular systems, the assembly lines that are still vital for things like, say, banking CAs,
Mhm.
all the way up to these incredibly powerful deep learning models, especially transformers, driving end-to-end systems that handle context memory and are now starting to unify complex tasks with natural chat. It's not just one replacing the other, is it? It's like we have different tools for different jobs.
That's a perfect summary. We have the reliable workhorse for specific defined tasks, and we have the incredibly context-aware, flexible network for tackling ambiguity and complexity. And, while today's models, ChatGPT, Bard, all the others are genuinely impressive, they can handle complex critiques and recommendations, they remember things across turns, the research is clear. This field is still moving incredibly fast. We're definitely not at the end of the road.
Right. So what does this all really mean for us, for you listening? It, it seems like while these CAs can be astonishingly good at mimicking human language and they're solving real high-value problems in areas like health and education, the consensus from the research is that we haven't actually found the definitive, complete solution to automatic conversation yet. There's still so much we don't know, so many challenges ahead. It highlights just how vast and maybe unexplored the true nature of conversation and intelligence really is. So here's a thought to leave you with. Next time you chat with an AI, what new facets of understanding or perhaps misunderstanding will you notice? What signs of intelligence or maybe just clever mimicry will you look for?